Dear students, today we are going to discuss the assembly level language program of 8051 microcontroller. So the given problem statement here is write an 8051 ASM program to read the temperature value T from RAM location 55H. According to the test results, place the temperature value into the register indicated below. So this is a RAM location where we need to send your input. This is a memory location. Okay. So this is an internal RAM. So 55H is your memory location. Okay. Here we need to give the data. Okay. So if temperature they have taken as a 30, that is a reference value they have took. Okay. If your input, let me say like a input is equal to 30, so both are equal, that will send to accumulator. That's it. If temperature not 30, let me say you have a 29, so that is 29 is less than 30. If condition is satisfied, I need to send that temperature value to the R1 register. If let me say your temperature value is 32, so obviously it is greater than 30, so I need to pass that value, the temperature value, to R2. So this is a logic you need to remember. So I'm repeating again. If temperature, if T is a reference value and you are getting your input, it may be anything, it may be equal to 30 or less than 30 or greater than 30. Suppose if it is equal to 30, I need to send to the accumulator. If it is less than 30, I need to send to R1 register. If it is greater than 30, I need to send to the R2 register. So this is a logic you need to remember. Okay. So next we will go to the program. So here this is starting address of your program. Move A55H. Okay, that means this is a memory location where we need to get your input. Okay, so this is a memory location. Now the accumulator have the value of 55H. This is a memory location. Okay, it's a memory location data you need to get. Okay, so this is address. So it is accumulator hold the data of 55 is a memory location. Okay, in the RAM. Okay, in the RAM it's a memory location where it's you need to give an input. Okay, now the RAM location is 55, I need to give a data. So that is the logic. Now we are introducing the new instruction CJNE, that is compare and jump if not equal. So this is a very important instruction. This instruction is used in many logics, in many problem statement, while doing ascending, descending, comparison. In many places it is very important. So what it do actually, very simple. Your input will be compare with a reference. See, if input is equal, it will save to accumulator that given temperature value. See here, CJNE A 30 is a reference and over is a label. If let me say I am giving input is 30, first case. If your input is 30, we know that 30 is equal to 30. That means the condition satisfied. So what it will do? Compare and jump if not equal. When it will jump if not equal. If it is equal, I need to send to the accumulator. That's all. Your accumulator hold the data 30. This is the first condition. Let me say case 2. In the case 2, I'm just assuming in the 55H I'm giving a data of 29. That means your input is less than, this is your input, right? This is your input. It is less than your reference value temperature. That means what I need to do? See, it is not equal, so condition fails here. Then I need to go to over. So over means here. If not equal, I need to go to the over. So in the over, what is the first instruction? JNC. What do you mean by JNC? Jump if no not carry is set. Okay, so 29 is less than 30. So surely you have a carry, right? Because this is the smallest number, this is the longest number. What is the instruction says? You want to jump if not carry is set. You have a carry, right? So then it will fail. This instruction it will skip and it will save that given 29, your input 29 to R1 register. So you can see here, if given value is less than 30, I need to save the temperature to R1. So that's what we are doing here, right? I am giving your R1, your accumulator, that is a temperature value, to R1. That's it. So let me say your case 3. If your input is 35, so in the case again it will come here. Okay, right, again it will come here. If it is greater, so condition fails, it's not equal, so again it will go to over and jump if not carry is set. So here no carry, because 35 is greater than 30, so it's a largest number, you don't have a carry, right? So I need to jump to next, so I need to pass your data to the R2, right? Then what I did, no operation, then is the end of the program. See here logic is very simple: compare and jump if not equal. If it is equal, I need to send your data. If temperature given input is equal to your reference value, I need to send your data to the accumulator. If input is less than your reference value, I need to send to R1 register. If your input is greater than your reference value, I need to send to R2 register. So this is a logic we have done in this program. Okay, in this program, so next program, write a program to check the port 1. Okay, so this is a port 1, whether it has a value of 45. If so, send 99H to P2, otherwise stay clear. So this is a logic, very simple logic. So here I need to check a port 1, right? So that means your port 1 is your input. I need to configure as a input. I need to configure port 2 as a output. So you very important to understand, when you are doing the read operation, that is a input, you are configure as an input, it is mandatory to configure as a input ports. Which port it is going to be a input, you need to configure. But similar case, when you want to configure any port as output, it is not mandatory, but here it is given just for your understanding. Okay, repeating again, here port 1 is declared as an input and port 2 is declared as an output. So what I am doing, if your input, if I am giving 45, same 45, if it is equal, if my input is 45, then both are equal, right? Then I need to send the data 99 to P2. If not, it should be stay clear. That means my data is 45. If my input, whatever I am giving input in the port 1 is 45, that means if I do 40, if I am giving 45, I am doing XOR operation here. We are doing XOR operation. The XOR operation, we know both are same. If your both input are same, you get a 0. So that is the logic we are performing here. So if I am giving 45, so it will do XOR with the 45, so we will get a 0. So condition is satisfied. So I need to send your 99 such to P2. This is the logic. If no, you need to remain stay clear. This is the logic. Okay, this is the starting line of your program, org000h. Now this P2 hash 00h. See, please understand 00. That means you have, see, P2 is a byte. It's a port. You have 8 bits, right? So you have it's a pin. You have 8 bits, right? So it can be written as in bits 00000. So in hexadecimal 00h. That means all ports are configured as a output port. So if I am saying, so I hope this is understood, right? So that means here I configured as a output port. Now I want to configure port 1 as an input port. That means in hexadecimal FF. In binary, how will write 1 1 1 1 1 1 1. That means in the port 1, in all the 8 pins, you know that the ranges will vary from 0 to 7. That means all the pins are configured as an input. How this FF comes? Because we know that 8 4 2 1. That means 1 1. F means what in hexadecimal? 15. So I will get 15. 1 1 1 1. That means 8 12 12 plus 2 14, 14 plus 15. That means all should be high. F. That means all the ports and all the bits are configured as the input ports. So this is only we configured as an input. This P2 is configured as output. So hereafter we need to give the data. See, if we are see, this is not a not a input which you given. This is port is configured as a input, that's it. Then we need to give a input. If your input is 45, then the condition will be performing, right? So these three instructions are clear, I hope. Then come to the fourth instruction. Now this is a reference value which you want to compare. So immediate value, that is R3 will hold the value of 45H. Now port 1, right, we want to give something. See, in the port 1 I can give 45 or 42 or something. Let me say your port 1 I'm giving 45. That means what is a 45? 45 months watts, how will be in the binary value? 8421. Okay, so your input, this is the input. Here what I'm going to do, I'm going to give 45 0101 0100, that is 40101, so 45. So in the switch, this from the least significant bit, first bit and third bit and sixth bit, all are make it as a high because those pins are given the input. Okay, so that means 45. So what is the reference value? Reference value is 45. So 000101. So now if you do XOR, you will get 00, right, because all are same. So we'll get 00. So now if you do XOR operation here, XOR, you get a 00. So what is the next condition? Jump of not 0, right? Jump of not 0, right? So you get a 00. Jump of not 0. When we need to jump, if there is no 0, right? So you have a 0, right? You have a 0, then you need not to jump. So this instruction will not execute, it will skip and will go to next instruction. So 99 will send to P2, that is we are writing. This is a reading, please understand, reading. This you are writing to port 2. So that's why we are configured port 2 as the output port. Okay, so you can understand. See, P1 is a read operation and P2 is a write operation. That means read operation means what? From the external world, you are sending to the microcontroller. Write operation means from the microcontroller it is going to the external world. Here this is a switch. Here I configured as an input port. Here this is an external device configured as an output port. Okay, so this is a very simple program to understand the bit level logic. Okay, so ports also you can understand. So repeating again, to configure any port as an input, configure, it is only configuring FF for input. If I want to configure any port as output, you need to give the immediate value of 00H. That means in the all the ports, in the ports, all the pins are configured as input. Let me you have a doubt, sir. Suppose I want to configure any one in the port, any one bit I need to configure as an input. What is the procedure? Set B P1.0. that means the port 1 zeroth bit I configured as an input. Similarly, set B port 2.3, that means in the second port the third bit is configured as a input. So this is a way to configure for bitwise and this is a way to configure for bytewise. Okay, so I hope you understood the program.